Hey there, this is Mr. Cristando, and in this video we're going to go over what's going on with the Bushwick horn snake. So the Bushwick horn snake is a snake that can only be found in Bushwick during the summer. The total length of the snake is measured in a special kind of unit called slithers. For example, after 1 year the snake will have a total of 7 slithers. Obviously this is a fictional problem, but let's take a look and see what's going on with the snake. So as we can see, in year 1, we have this basic shape here where, it looks like a tail, and then we can see the horns over here. Then we can see some growth happening in that tail and some growth happening in the horns. Let's take it a little bit further and let's see exactly what's going on here. So how is this thing growing? So if we count it in year 1, we can see that there is 4 plus 3. That's going to be a total of 7 slithers. Similarly, in year 2, if we count this, there's going to be 6 on the bottom, and then looks like 5 on the top. So that's going to be a total of 11 slithers. And if we count the next one, we're going to get a total of 15 slithers. Okay? So at this point, if you guys kind of read number 1, it says, in your own words, describe how the snake is growing. I think we can kind of assume that it's going to be a constant rate of change of, slithers increasing by 4 as the year is increasing by 1. But let's take it a little bit further and let's actually draw year 0 and year 4 just to kind of get a better idea here. So over here, if we go back, here's year 0, okay? And over here is year 4. And if you're asking yourself, how did I draw that? Well, it's from noticing this pattern. So it's from noticing that there's this growth happening here by 2, and then there's also this growth happening each time by 2 in the horns. So we have an additional 2 here and an additional 2 here. Okay, so using that could get us back to go to year 0 and year 4. Okay, so at this point, what I would probably do is I'd probably jump to a table just to kind of see exactly what's happening here. So here's a table. All right, and we'll have years. We'll have S for slithers. Alright, we have 0, 1, 2, 3, 4, 5, right? And I'd start filling in some of our information. So it looks like this thing is starting with 3 slithers, and then from before we know it's 7, 11, 15. Okay? So at this point, I think you should be able to realize that, hey, this thing is increasing by 4 each time. So that being said, we could definitely easily figure out figure 4 and figure 5 to be 19, and then of course 23. Okay? So like we said before, this would be a constant rate of change because it's increasing by the same amount of slithers each time. Sorry, let me get that 4 in there. Okay? So that kind of answers our first question. And I have that here. So as the years increase by 1, the amount of slithers increases by 4. The tail grows out by 2 slithers each year, and each horn increases by 1. So if you are trying to edit that problem, that's a pretty good response. I saw a mixture of those two things. So some people describing how the picture grew, and other people just kind of looking at it numerically. Either one's fine, but that's a combination of the two. So now they're asking us how many slithers are there in year 10, and of course show our work. So one thing you could do is you could jump down in the table and you could just keep adding 4 and 4 and 4, which a lot of folks did that. Or you could be kind of strategic here, which will get us towards writing an equation for this, and you could just simply ask yourself 2 questions. The first question is, hey, how many slithers does this thing start with? Well, it starts with 3. When it's born, it's a total of 3 slithers, okay, baby snake. And then ask yourself, alright, so how many times am I going to add 4 if I'm starting at 3? Well, looking at this, it looks like if we jump from 0 all the way to year, say, 10, we're jumping by 10 years, so that means we're going to be adding 4, 1, 2, 3, 4, all the way up 10 times. So here's what a calculation would look like. So we're starting with 3, okay? And then we're adding 4 10 times, okay? putting this together, be 3 plus 40, of course, that would be 43. Okay, so that's a general way to do this without having to jump all the way down the table and just add 4, you know? And again, that's going to kind of lead us towards an equation. So using that same reasoning, all right, if we want to write an equation for this, okay, so we'll call this thing, I don't know, call it S of X, so for slithers, right? And similarly, the equation would be the same thing. So it's, instead of having 10 years, we have some unknown amount of years. So we're just asking ourselves this question, how many times are we going to add 4? Well, we're going to add 4 x times. Okay, so 4 x times, whatever that year is, okay? And then, of course, we also have to ask ourselves, well, how much does it start with? Well, it starts with 3. Okay, so that means that we are adding 3 to whatever that calculation is. And, you know, if you want to test this thing, you know, just test it out. So, I don't know, let's test it with year 2. Let's see if it works. So, year 2, that'd be 4 times 2 plus 3. That'd be 8 plus 3. Of course, we get 11. So that's a way for us to make sure that this thing works. I would usually test it with like 2 or more just to be sure, but yeah, so we can definitely see that this thing works, okay? So now, using this equation, this is going to kind of help us out now as we go to answer a question like 4. So it says, Snooki says that there is a year when the snake will be exactly 274 slithers. She's wrong. Explain why she's wrong. So there's a couple different ways we could do this. One way is we could guess and check. So like we could keep doing this and we could try different years in here and see if we could ever get to 274, you know? That's going to take a little longer than some other methods. If I were doing this without using the equation, well, I mean, technically you have to use the equation to do this. I would use technology. So go into your calculator. Let's go into the table. All right. And let's put in our equation, which was 4x plus 3. Okay, so there's our equation. Let's set that calculator to go from, I don't know, let's start at year 0 because we know the snake is, you know, born in year 0. And I don't know, let's make it go to, I don't know, how about 100? 100 years, right? That should take us pretty far. So here's our table, right? So we're going to jump down, jump down. So I'm like waiting for this thing to get to 274. Yep, any day now. And there we go. And there's the answer to our problem. So, if you're looking at this, we could see that, hey, Snooki is definitely wrong because year 67 has 271 and year 68 has 275. So then there is no way you could have 274. Definitely incorrect here. Okay? So, another way to do this, if you don't want to do it that way, is you could actually use your equation if you're comfortable with what these things represent. So when we wrote this equation with x representing years and s of x representing the amount of slithers. So in this situation, we know the amount of slithers, but what we don't know is the year of which that would happen. So we could go into our equation, and instead of s of x, we'll have 274 slithers. And then the question is hey, what is x going to be when that happens? So doing some algebra, you know, we could eliminate this 3. So eliminating that 3, we're going to have 271 is equal to 4x. Let's eliminate that 4. Okay, if we do this, you know, let's see what 271 divided by 4 is. And then there you go. So we're getting a decimal answer, and in this problem, we're only talking about the years as they are whole numbers. Okay, so there's no exact year in which that will happen. So that is another way of which you could do this. Okay, so I hope this video was helpful. Stay tuned. We're going to put up another video for the second problem, the Pride of Trinidad. And that's it. Have a good one.